So with that, I'm going to turn it over to John to get us started with the Q&A.
Great, thank you, Matt, and thank you, Andrew. Do you want to reintroduce Matt Pogue? He's the Huntsman Senior Account Manager. Matt, how you doing?
Pretty good, and big thanks to the Chemical Concepts team for arranging this session here. I think it went really well. You know, it's always great to have some live demos. Big thanks to Matt Freeman here for doing that. And I think, you know, it's great when we get to see the adhesives in action. So again, big thanks to you guys. I'm happy to be here, and thank you for the invitation.
Awesome. Well, let's get into the Q&A then, guys. I did get a couple questions during the presentation there. A lot focusing on dissimilar materials. Matt, I'll let you lead this off. We got a question here from an anonymous attendee. When talking about dissimilar materials, what kind of materials are related? So this person brought up metal to composite, plastic to metal, aluminum to steel. What would be your generic answer in that?
Yeah, I'll go ahead and take that one. Okay. Yeah, so the dissimilar materials, it really covers all those. I mean, if you're going to be bonding any kind of metal to composites, or even different types of composites together that might not, you know, be an exact match, then these adhesives are going to be able to withstand those different changes and be able to bond both sides of it.
Yeah, and the thing I would add there is, you know, the one big consideration, and that's something especially engineers ask us about a lot, is that coefficient of thermal expansion. So, you know, if you're not familiar, you know, all the different materials, they expand and contract at different rates. So if you have two materials and you're putting them next to each other and you're trying to join them together, you have to be able to compensate for that. So compared to, say, welding, which doesn't have, well, you know, if you're doing, say, aluminum to stainless or even metal to composites, you know, welding isn't even an option necessarily to begin with. But whatever joining, you know, looking at mechanical fasteners, you want to make sure that you're allowing for some of that movement. So if you, you know, going through some of those specs, all the adhesives have some movement capability, some more than others. And I hope it's okay for you guys to plug the new material, right? But you have the 2053 that's coming out soon. And that's going to be a material that's got even more elongation, even more movement capability for an acrylic that could come in handy in some of these situations where, you know, in some of these temperature extremes, you know, the longer that you have apart, you know, or the bigger the area that you have, you know, that thermal expansion can be more significant. So say if that thermal expansion is, say, 10%, you know, 10% of a millimeter is still in absolute terms a small number. That bigger that area gets, that expansion can become more and more significant. So it becomes more and more important to have an adhesive with a lot of flexibility. So are you guys able, just to kind of a little tangent, are you guys able to talk about the 2053 at all? You know, I don't know if you guys would probably know better than me off the top of your heads what the expansion rates or the elongation on that product is.
Yeah, so I don't have all the data off the top of my head, but I do know the elongation on that one is going to be greater than 50%. So it is going to offer a lot of ability to have that flexibility on these different materials that even with the high CTE, they'll be able to withstand that.
Yeah, as it pertains to the question, I think you brought up a good point, Andrew, is that, you know, when you do have those dissimilar substrates, the CTEs are not going to match. And, you know, in the typical days, if you were bonding composites with an epoxy formulation backbone, you typically want to use an epoxy adhesive so that CTEs would be somewhat similar. With the 2053, we get around that issue because of the elongation and the toughness of the product. That's not as much of a concern right now. So you do get the benefits of the MMA chemistry, but you don't get the disadvantage of any type of delamination or adhesive failure.
Yeah. So I think bottom line for the person that asked that question is, you know, if you have a specific combination of materials, you know, let us know and we can help you select the right tool for that job. But almost, you know, almost any two materials, we probably have a solution that will work. We'll certainly let you know if we can't, but come to us with any application and we'll certainly, you know, and as you can see, you've got a little bird's eye view into the lab there at Huntsman. So if we don't know if we don't have data, oh, you know what, we've never bonded fiberglass to stainless steel using this product. Let's see if it works. So we do have testing facilities and those resources available depending on what you're doing. So that's where I kind of wanted to leave that there.
Thanks, guys. Got another question here from Richard. We have nothing was mentioned on wood. Is there a specific product or recommendation or product line you guys would recommend for wood to metal, concrete, plastics?
For wood, I don't know that we've done a lot of testing on. I'm sure, I know they'll stick to wood. I don't know about as far as the durability. That would be something that would have to be tested, of course, but the adhesives will stick to it for sure.
Yeah, I think that would probably come more down to the particular mechanical requirements of the application. So again, that's another opportunity to interface with chemical concepts to provide some more detail about the specific application. And that would probably really help us determine which adhesive solution would be the best for that particular bonding.
Yeah, and if I could add something there, just to speak in really general terms, you know, we're learning about the Huntsman products all the time. As I mentioned, we've only been a Huntsman distributor for about 3 months now. So tomorrow will be the beginning of the 4th month. We started January 1st. So we're still kind of learning all the intricacies of and the specifics of and the peculiarities of their products. But just in general terms, in terms of the chemistries, so the chemistries that Huntsman offers, we've got epoxies, acrylics, urethanes. In our experience, when doing product selection, one of the things that we look at is porous versus non-porous substrates. So what we usually advise customers, if you have a really porous substrate, then epoxies tend to work better. Epoxies and urethanes tend to work better. The acrylics tend to work better on the non-porous substrates, so like plastics or metals that don't have that porosity. So I would imagine that most of the and that's, maybe there's exceptions here or there. Okay, here's an acrylic that just happens to stick really well to concrete or whatever. But I think in general terms, that's a good guideline, not a rule. And so for bonding wood, you mentioned a couple of combinations. So you say like wood to metal. So in general, I would say probably an epoxy would be the best solution to that. And then we could kind of work with you to figure out which epoxy is maybe the best fit. And then if you're doing to say wood to like a plastic or wood to a non-porous substrate, other than metal, because actually the urethanes don't bond metal fantastic. So that's why I said an epoxy, but a urethane would also be a good choice. So say if you're doing wood to plastic, or wood to composite or something like that, we've had good results. So hopefully that helps.
Yeah, and speaking on the concrete portion, we did have an application with a customer that was using concrete onto a composite part, and it was the 2015-1, and they had great results with it. It did everything they wanted, and it's an outside application, so that weathering for the 2015 was a big help for them as well. Yeah,
and then with wood, I mean, obviously the different hardwoods, they're very, a lot of, it's a big umbrella term. So, teak is obviously a very different wood than, pine, especially for those of you in the marine industry, the special properties of teak. So, but in general, like the more porous woods, the softer woods, it's definitely an easy material to bond. So I wouldn't have a lot of concern about that. It's got those big open pores. The epoxy, if it's a lower viscosity epoxy, it can kind of flow in there. And usually if we do destructive testing or something like that, you're seeing material failure. You're seeing, you're pulling wood off of, you're pulling material off of that wood. So generally it's the other side, that's going to be the limiting factor, is the material itself, basically.
Great, thanks, guys. Another question here. You had mentioned, this was another anonymous attendee. Which products should be used when bonding aluminum and then powder coating? I know we talked about an application.
Great question.
But can you elaborate a little bit more on the powder coating and what products you would use?
Yes, so the ARALDITE 2050 and 2051, they have had examples of where they were bonded and then powder coated. And then also our new adhesive that we mentioned just a little bit earlier, the 2053, it's also been used in that application as well. And it's going to be able to withstand those temperatures, at least for, the time that it's in the powder coating.
Yeah. So that's another, I kind of mentioned it up front, but I don't think we had a specific case study that went into that, but that's a great extreme condition. That's pretty common. And, we talked about like weather and like natural events, but, a lot of people and manufacturers are looking for products that can withstand the different processes that they have in their in their assembly process. So if it has to survive the e-coating process or the powder coating process, or maybe there's another heated element for another part of the process that it needs to survive. So that's important as well. And we have with a variety of adhesives, we have a lot of experience with applications where powder coating is part of the process. And especially looking at the data sheet, you mentioned the 2051 and the 2053. Is that right? Is that what you guys mentioned?
Yes.
Yeah. So if you look at the high temperature resistance on that product, you might immediately look at it and say, oh, I think it says 285 degrees Fahrenheit or something like that. You might say, oh, it doesn't go hot enough, but that's a prolonged temperature. So it can handle higher temperatures for an intermittent period of time, right? So the one thing we advise customers, usually if you talk to your powder coater, if you're sending this out, if you either have control of the powder coating process, that's great. If you're sending it out, usually you can request that the powder coating process will still work at a range of temperatures. So we just try and advise people to keep it under 400. So we've had a lot of success with customers that are powder coating parts using adhesives, and they've run those powder coating ovens at like 385, 390, something like that. Try and keep it under the 400 mark if you can. And the other rule of thumb that we tell people is what's going to happen is that adhesive is going to soften. And then after it comes out of the powder coating oven, that's going to re-solidify and go back to its cured state. But while it's soft, once it's re-hardens, it's actually stronger than it was before. That post-baking actually helps some of the cross-linking. But while it's in that heated state, it's going to be a little bit soft. So I wouldn't hang parts directly from, so if you're bonding a clip on, don't hang the whole part from a clip that you just bonded. Make sure that you have a secure area to hang the part from, because the performance of the adhesive will temporarily be lower. If you pull that thing out of the oven and immediately try and pull that part off, you probably could. But after it comes down to room temperature, you'll have no change in the long-term performance. So that's just an important tidbit for any of you that are looking at powder coating products.
Just a question from my side. I mean, we have plenty of people that will call us about, post powder coating. Is there a product you guys would recommend for something after the powder coat process to bond, the parts together?
We have a lot of different adhesives that could work on that, but on the powder coating itself, it's probably going to need still some kind of surface prep, most likely, to be able to get that long-lasting, durable bond, because it's not going to bond directly on that and just be able to work right off of it. It's going to need some kind of surface prep onto that to get that adhesive to work.
Yeah, those powder coating, some of those formulations, they can be very slick, very low surface energy. So, even like a light scuff and some kind of alcohol cleaning. And, generally we could have good results, whether it's before or after the powder coating process. And, in terms of chemistry, I think we've used some of the urethane stick to powder coat pretty well. You guys, I don't know if you know offhand with the acrylics, do you have good results on sticking, at least after they're prepared, to sticking to powder coat?
Yeah, I think we've had a few different examples with it being applied to that and had pretty good results. But yeah, it's usually at least some kind of surface prep. If anything, like you mentioned, a wipe or something, or a light scuff, something to give it something to hold on to be able to make that bond.
Yep.
Perfect. I got a question here from Robert. Thank you, Robert. He said, I'm interested in adhesives that have glass spacer beads integrated into them. Does Huntsman carry a product that can adhere plastic to aluminum that has these glass beads in them?
So two of our adhesives on the core range do have those glass spacer beads already integrated in, which is the 2031-1 and the 2019 that I spoke about. And both of those should have a good adhesion to aluminum. And did you say onto plastic?
Yeah, he mentioned plastic to aluminum.
Okay, plastic.
I don't have that in there.
Hey, Robert, if you're still with us, do you know what type of plastic that you have? But while we might be getting an answer to that, so I'll just throw a hypothetical at you. So say it's like, say, ABS or acrylic or a pretty common plastic like that. I mean, what would you say there? Would one of those two products work well?
So with those two, yeah, depending on how strong of a bond you want, both of those products will work on those materials. We do have data on those in the TDS. So depending on how high you need that lap shear strength or any tensile strength to be, then those would be two possible options.
Yeah. So the really tough plastics, as some of you guys might know, are like the polyolefins, so like the HDPE and the polypropylene, PTFE. Even nylon is kind of tough to stick to. I don't know if you guys can tell me if you feel like the either of those two products would stick well to nylon. But in general, those are the kind of tougher products that we commonly run into, and you either need a special product for that or at least a special treatment. Like you could do corona treatment or plasma treatment on HDPE that'll help prepare the surface and give you good results.
Yeah, that's the key right there, especially with the low energy substrates. It really comes down to the mechanical requirements of the application, and then also what surface treatments are available to be conducted onto the substrates themselves, because that can make a big difference on your adhesion, especially those materials.
Yeah. Something else I wanted to add is here's another concept for you. Something else that Chemical Concept sells as an accessory. We actually sell little bottles of glass beads that are almost like in a little salt shaker. And it's kind of lower tech than having an adhesive that's got the glass beads already mixed in. But that does give you the flexibility to use any adhesive that you want. You could just lay a bead down. Your operator could have a little bottle of glass beads, just pour a small amount on there. Maybe in your process, depending on how tightly controlled, if you're doing medical devices, you want everything dosed out, maybe you can't do that. But depending on the requirements, if it's easy for you to just sprinkle some glass beads on the top, and then when you bond those parts together, I would think you'd get pretty similar performance. And we do have customers that have done those kinds of applications. So the glass beads that we carry, they're 10 mil glass beads. So it's 10,000ths of an inch, which is really a good bond line thickness for most adhesives, where you'll get that consistent bond line thickness that you're looking for. So another option for you if the exact adhesive that you'd want to use is not available with glass beads.
Great, thanks guys. Derek asked a question. Thank you, Derek. He said he mentioned that the core range chart that we showed on one of the last slides there was most interesting to him. Derek, we can send this to you, but can you elaborate a little bit? I know you kind of went through it quickly, but can you elaborate a little bit more on how to work that core range chart that you have, that wheel?
Yeah. So I can kind of go back over that again. So you can see the three different rings. The inside ring is where you would start at. That's the pot life. So depending on how long you want that adhesive to be workable before it starts to gel is where you'll go from there. And so once you know that, then you can pick which section of that ring it falls in. So for instance, if it's 10 minutes, you go from less than 10-minute pot life, you'll move out to that second ring, and that's the max operating temperature. So on there, it has three different sections for the operating temperature that you'll need your adhesive to withstand. And that's when we say operating temperature, that's any temperature that'll be exposed to consistently, it can withstand those temperatures. So like Andrew mentioned, we can get beyond that for short periods of time, but if you want that consistent operating temperature, that's where you'll go for that second ring. And after you have those two sections picked out, you'll move up to that third ring where it has the composites, metal, or plastic. And it shows right above that, the little grayed in section will be the adhesive that fits into that distinct area. So that meets all three criteria.
Yeah, so this gives you a great starting point, but then of course, feel free to lean on us and lean on the Huntsman people. If you have a specific application, we'll certainly help you, pick the right tool for the job. And, those tools are great. And then, but what we were able to do is kind of leverage some of the past experience we've had. Oh yeah, you know what? I just helped somebody 2 weeks ago that had a similar application, or I've got a customer that's been doing something similar for years, and we're able to kind of leverage that kind of stuff too. So we're here to help either way.
Great, thanks guys. Ralph here asked a question. Thank you, Ralph. Basically, it's a two-part question. So I'll ask the first one. What dictates whether you use an acrylic versus a polyurethane versus an epoxy when adhering painted or powder coated steel and like component pieces? So his concern, I guess I'll just jump in the whole question here. His concern is the general public, and Ralph, you can elaborate on this a little bit more. call us or email us anytime. But you said the general public can come into contact with this, lean against it, or impact it. Looks like they're fabricating decorative steel elements to railing components. So, you know, obviously there's some impact and some you know, touching and things like that. So where would you start, at least as far as selecting the right adhesive, and what would you recommend for something in that application?
Yeah, so you would really start with how strong I'm assuming you would have some kind of test saying how strong you need that bond to be, and that would be your starting point. As far as people touching it, once these adhesives are cured, none of them are going to cause any kind of any detrimental impact of if somebody touched it, like they'd have to wash their hands or something. Once these adhesives are cured, they're completely safe. And then also, if it's going to be exposed to any other environments, for example, like if it's next to the ocean, if it's going to have saltwater spray or something, you're going to need that chemical resistance and that saltwater resistance. Most likely the MMAs or the epoxies are going to be able to have more chemical resistance and better resistance to that. If you have, depending on what the parts are, if it's just metal to metal, then epoxy or MMA would work fine. If you need something that's going to be a little more flexible, that'd be the polyurethane. And depending on how the bond line is, if you want it to be clear, if color is important, that's another factor that you can look at as well.
Yeah, my personal opinion on that question is if it truly is something that's going to be out in the elements, and surface prep is something that can be done to the powder coat. I personally probably start with the epoxy line, something maybe like the 2015-1. It's a very, very tough end weather resistant product. The 2019 would also be something I would look at if a post cure can be done on the adhesive as well.
So in terms of like long-term durability or anything like that, do you feel like once the product is, you know, so assuming you have a good epoxy choice or a good acrylic choice that bonds well to the substrates, once it's in its cured state and finished and in use, do you see any kind of durability difference or long-term performance of epoxy versus any of the, you know, epoxy versus acrylic versus urethane?
Say that the epoxies are usually able to be more durable and they're going to be longer lasting. The MMAs are pretty good as well, but the epoxies are really built for that. I mean, once they're there, they're going to stay there for a long time. It's going to be pretty much impossible to get rid of them.
Right. So, you know, the other thing of that is all the other stuff that goes into your process. So one of the key differences between epoxies and acrylics is the curve of the cure and the length of cure. So how fast do you need to get to that handling strength, and how fast do you want to work with the materials? So there are some pretty fast epoxies, but typically with epoxies, the faster the epoxy that you get, usually they're not as strong. And again, these are big general terms. There might be exceptions, but normally if you want the strongest epoxy, those tend to be kind of longer open time products. So if you want that combination of really high strength, but also really high fast, but really high speed, and then fast buildup of strength, that's where an acrylic maybe makes more sense. And so the thing that we look at is the cure curve. So in general terms, epoxies tend to have linear curves. So if you just plot on a line chart the curing cycle at 100% cured, it's taken 100% of the cure time. At 50% of the curing time, it's 50% cured. You've hit 50% of your strength, etc. Where if you graph the way acrylics build up strength, they're kind of more of a exponential curve where most of that strength accumulation happens in the first 2 hours, in the first 4 hours or something. So if you need to glue this thing together and then within 8 hours, this thing's going to have some kind of stress on it, then an acrylic might be a better choice. So kind of a long answer to a simple question, but those are the kinds of things in the process where that might help kind of guide. When I'm talking to people, those are the kinds of things, the questions I'm trying to ask to try and gauge, okay, what's the best fit for this application? Because in reality, it's a good question because there's a lot of overlap. There's probably a lot of applications where in reality, a urethane, an epoxy, or an acrylic could work. It's just a matter of what's best for you.
Great, thanks, Andrew. I got another great question here from an attendee. What product is recommended when bonding thin materials such as 0.02 aluminum to avoid distortion due to heat. So that's like what we call, Andrew, and you can elaborate on this, read through. There's oil canning. I've heard that term. I don't know if you have any answers.
Telegraphing. Yeah.
Yeah.
What would you guys say to that?
Yeah, I think, the 2053 and some of the other MMAs, we've done some work where we try to mitigate the read-through issues. Automotive, that's a huge concern, of course, especially when you're working with these newer composite parts and thermoplastic parts. I think it really comes down to testing out the particular substrates for those applications, which here in the lab, we're more than welcome any submissions or questions for that pertaining to those specific applications, because there's a lot of variability. But I think in general, the 2053, I've heard it's commonly been looked at for mitigating the read-through.
Yeah, and that's a good suggestion, because the big thing there is the flexibility. So it's that you need a little bit of flexibility there to allow the parts to move without, because what's happening there is that the parts are trying to move, the adhesive is rigid, it can't. So wherever that adhesive is, that becomes a point where there's maybe a slight bow or a bend in the material. So the more that adhesive can compensate, kind of the better. So that's where kind of my head was going to immediately when I saw the question. Yeah.
Great. Thanks, guys. Just a general question for me. I mean, I see that, in the demos, we use those 50 milliliter, cartridges. What kind of packaging sizes? Do you guys have bulk packaging sizes? Like what are the options for these engineers or applicators?
Yeah, so we have like you see, the 50 mil cartridges. We also have different adhesives have different pack sizes, but we'll have 200 mil cartridges or 400 mil cartridges as well. And also like quart size or pail, and then also in drum size, bulk, depending on the adhesive and what your needs are, we probably have a pack size for you.
Perfect.
Okay. Yeah, and another thing that I just kind of want to say, since if you guys are looking at applications involving adhesives, we've tried to send some kind of communications out, talking about basically the supply environment that we're in right now. So just to kind of let everybody know, if you're not aware, obviously you've probably seen on the news, there's a lot of things impacting supply chains. So it is kind of a tough time just in the chemical industry in general right now. So my message to you guys is, if you have an application that you're working on or you're looking for a right adhesive, just make sure to budget in as much time as you can into the process. Hopefully things kind of go back to, normal, whatever that means, sooner than later. But not just Huntsman, all the suppliers that we're working with, we're all kind of struggling with, extended lead times, delays, and that kind of stuff. So very important in this planning phase to just kind of be aware of that, because what we'd hate to do is walk you through a whole process, find the right adhesive for you, and then it doesn't meet your timeline or something like that. So very important for everybody.
Yeah, definitely make sure as soon as possible, if you have an application that you think you could use our adhesives, bring us in as soon as possible, so we could get you in queue, because we do have like backlog of customers that want adhesives, and you want to make sure that you get in as soon as possible.
Right. Okay. Well, we're getting towards the top of the hour, which is the amount that we had budgeted. I see in the Q&A box most of the questions have been answered. Maybe we have time for one or two more. I see Ralph jumped in.
Sure.
Yeah, Ralph, he's asking, he actually added a little bit to his application. He said he's making flat stainless metal shields to go on upright railing legs, to be used in a stadium, where it can be banged and abused when people get out of hand, which is known to happen here in Philadelphia. I'll tell you that much.
Yeah, it's got to be Philly tough. Do you have any Philly tough adhesives, guys?
So his question is, he's got these these shields, and they want to make sure they're not falling off these railing components. So would there be an adhesive you guys would recommend for these shields to these railings?
Yeah, I think for that application, as long as you're willing to do a little surface prep, the 2015-1 would be a great adhesive for it. And with that surface prep, it's going to make a really strong bond. It's going to, hold up to a lot of abuse. We'll see if it can hold up to the Philly Strong, but
it's pretty
That
cool.
remains to be seen.
Yeah, I think that's a Philly Tough adhesive. It is a very, very resilient system. So that would be what I lead off. So yeah, I think the key is surface prep and option. I would highly recommend it if possible. If that's the type of environment and it's going to be beat on day after day and take a beating for many years, 2015 would be a great fit for that application.
Yeah, and good news, going back to the supply issues, you know, we do have some 2015 in stock. So if that's something that you wanted to test out, we'd be able to get that in your hands sooner than later for you to be able to play around with it and see if it meets that high bar that we're setting here.
Yep.
Okay, any other final questions? All right, I'll take that silence forever, hold your peace, all that. Thanks for all the questions, everybody. So, all right, with that, we're ready to wrap up. So a big thanks to Huntsman, thanks to Matt Freeman, thanks to Matt Pogue, thanks to the whole rest of the Huntsman team behind the scenes that helped get us here. And thanks to everybody on my team that helped make this possible. And of course, the biggest thanks to you guys, the attendees, for sticking with us literally and hearing learning a little bit more about these products, and hopefully you found it valuable. So again, you're going to get some communications from us, including a recording, including the PDF, and you'll be hearing from us shortly to see if there's anything we can help you with. Thanks again, and enjoy the rest of your day.
Thanks.
Thank you.
Take care, everybody. So long.